All right, let's jump right into this. Picture this. You're standing out in a pasture, and you hand a dairy cow a fresh green bundle of grass. On the surface, it looks like the most ordinary, mundane meal in the world, right? But inside her rumen, an absolutely extraordinary, microscopic transformation is about to kick off. Today, we're unpacking the hidden microbial economy that literally makes dairy production possible.
So it really begs the question, what is actually happening when a cow chows down on some grass? Well, that grass is absolutely packed with carbohydrates, the main energy source for plants. Now, sure, some of these are just simple sugars or starch, but the vast majority of that grass is made up of an incredibly tough carbohydrate called cellulose. And here is the wild part. Humans, we can't digest cellulose at all. But a cow doesn't actually have to do it alone. She is housing billions, literally billions of microscopic partners living right inside her rumen that can break it all down for her.
The second those carbohydrates hit the rumen, it is on. It's like a microscopic gold rush. Billions of bacteria, protozoa, and fungi immediately swarm and attack the feed particles. But, and this is key, they don't simply eat the grass, they ferment it. If you've ever baked bread and watched yeast ferment sugar, or, say, seen yogurt bacteria ferment milk, well, it's that exact same biological magic happening right inside the cow.
Now, here's where things get super interesting. During this intense fermentation process, these carbs don't just magically turn into glucose like they do in humans. Instead, the microbes convert them into three really remarkable compounds known as volatile fatty acids, or VFAs for short. Think of these three acids, acetate, propionate, and butyrate, as the cow's primary energy currencies.
And we are talking about a massive energy economy here. Get this, these three microscopic acids, which are produced entirely by the bugs in our stomach, supply nearly 70% of the cow's total daily energy needs. 70%! That is an astonishing amount of power being generated purely by fermentation. And here's the detail that completely redefines how we look at the cow's anatomy. Unlike most animals, animals that have to wait for food to travel all the way down to the intestines to absorb any real energy, the dairy cow doesn't wait. These volatile fatty acids are absorbed directly through the wall of the rumen straight into her bloodstream. The rumen isn't just some holding tank or fermentation vat. It is a highly active, energy-absorbing organ in its own right.
All right, let's move into part one of this breakdown, the currency exchange, looking closely at acetate versus propionate.
This exchange is literally where the science turns into the milk sitting in your fridge right now. On one side of the scale, we have acetate. Now, this is the most abundant VFA in the rumen, and it's produced mostly when the cow eats fiber-rich feeds. Think grass, hay, silage. Acetate travels through the bloodstream and acts as the primary building block for milk fat. That is exactly why cows fed plenty of fiber give milk with a much higher fat percentage. But let's look at the other side of the equation, propionate. This acid comes mostly from starch-rich feeds, like corn and grains. Propionate actually doesn't build fat at all. Instead, it travels straight to the liver where it is converted into glucose. That glucose is then used to produce lactose, which is milk sugar. And lactose? Well, that is the main driver of how much milk volume a cow can actually produce. So basically, if propionate drops, glucose drops, and the overall milk yield declines right along with it.
Which brings us to part two, the local fuel, or butyrate.
So, butyrate is kind of the underdog here. It's produced in way smaller amounts than acetate or propionate, but its job is absolutely crucial. Think of butyrate as the operational budget for the rumen factory itself. The actual cells lining the rumen wall use butyrate for their own energy, which is what keeps the organ healthy and functioning at peak efficiency. Plus, on top of that, some of it gets converted into ketone bodies, which gives the cow a really neat secondary source of extra energy.
So, pulling all this together, feeding a dairy cow is essentially managing a microscopic economy. The balance between these three VFAs depends entirely on what the cow is eating on any given day. If you feed more forage, well, you drive up the acetate and you get higher milk fat. If you feed more grain, you're going to drive up the propionate and push that milk volume. But here's the catch. You need all three. A perfectly balanced diet maintains the right proportions of these acids, which supports rumen health, optimizes the milk production, and just keeps the whole biological system humming along safely. But all of this delicate balance leads us to a pretty massive, unavoidable question. What happens if we chase milk volume a little too hard? What happens when feeding too much grain causes this incredibly delicate microbial fermentation process to just spiral out of control? Next time, we are going to dive into the darker side of this microscopic economy and uncover the real dangers of rumen acidosis. It's a fascinating side of the science and definitely something you'll want to stick around for. Catch you then!